In this video, I am going to discuss about weldability, factors affecting weldability, weld zone in a welded joint, heat affected zone, preheating and post-heating of welded joints. Weldability. Weldability is defined as the ability of a material to be get welded. It is nothing but ability of a material to be get welded. Weldability is simply a measure of how easy it is to make a weld in a particular material without crack. So weldability is defined as the ability of a material to be get weld without forming a crack. Factors affecting weldability: melting point of the material, thermal conductivity of the material, reactivity, coefficient of thermal expansion, electrical resistance, surface condition of the material. So these are the factors which affect the weldability of a material. Weld zone. A welded joint consists three distinct zones. First one, weld metal zone. Second one, heat affected zone. It is also known as HAZ. Then third one is unaffected base metal or parent metal. So these are the three distinct zones in a welded joint: weld metal zone, heat affected zone, unaffected base metal or parent metal. So first one, weld metal zone. So this is a welded joint. There are three distinct zones in a welded joint. That is fusion zone first. It is also known as weld metal zone. Then heat affected zone, that is known as HAZ. Then third one is unaffected base metal. So this is a fusion zone. This is HAZ and this is the unaffected base metal. So first one is weld metal zone. See, weld metal zone is the fusion zone, that is the material become molten state during welding process. When a filler metal is used, the central zone consists of a mixture of base metal and filler metal. This is called weld metal. When filler metal is not used, the central zone is composed of resolidified base metal. So weld zone is the fusion zone or central zone where molten weld metal is present. If the filler metal is not used, the central zone consists only molten weld metal, that is molten base metal. If filler metal is used, the central zone or fusion zone consists molten filler metal and molten base metal. See, during welding process, the intense heat will melt the base metal and filler metal in the fusion zone. This molten metal is later allowed to cool down to the room temperature and solidify. During solidification, columnar grains are formed. These columnar grains grow parallel and opposite to the direction of heat flow. That's very important. See what is happened during a process, during a welding process. During a welding process, the base metal is heated, it is melted, a molten weld pool is created. Into that molten weld pool, additional material is adding in the form of filler material. So after solidification, during solidification, the heat will be liberated to the surrounding atmosphere and liquid metal is converted into solid state. So during solidification, new grains will be developed. So in a fusion zone, always columnar grain structure will be formed. So these are the columnar grain structure that will grow in parallel direction opposite to the heat flow. So this is the heat flow direction. Actually, this is the heat flow direction. You can see that. And the columnar grains that will be grow opposite to the heat flow. So these are the columnar grain structure. So fusion zone always consists of columnar grain structure which will grow opposite to the heat flow direction. next one is heat affected zone. Second portion is the heat affected zone. See, during the welding process, some portion of base metal is heated to higher temperature that are below the melting point and then slowly cooled. This region of base metal is called heat affected zone or HAZ. Due to the heating and cooling, the microstructural changes happen to HAZ. See, what is HAZ? See, during the welding process, the portion of material which is nearer to fusion zone is get heated up to below melting point and then cooled. This heating and cooling causes microstructural changes in that portion of material, and that portion is known as HAZ, heat affected zone. And third portion is the heat affected zone is here. This is the heat affected zone. You can see this is the heat affected zone, just near to the fusion zone. So in the case of heat affected zone, fine grained structure will be produced HAZ away from weld interface. That means away from the weld interface or fusion zone, fine grained microstructure will be formed. Very near to fusion zone, coarse grained microstructure will be formed in the HAZ, and this entire portion is known as HAZ. So what is the case of HAZ is, during welding process the HAZ is heated and cooled, and there should be microstructural change will be happening in the HAZ. So there will be fine coarse grained structure that will be produced in the area very near to fusion zone, and fine grained structure that will be produced in the area far away from fusion zone in heat affected zone or HAZ. Okay, and the third portion is the original cold material, base metal, that is not undergo any microstructural change, that is unaffected base metal or parent metal. So these are the three regions in a welded joints: weld metal, heat affected zone, and unaffected base metal or parent metal. So next one is HAZ, heat affected zone. See, heat affected zone is a portion or area of a metal that has not been melted and has undergone change in properties as a result of being exposed to relatively high temperature during welding. So what is heat affected zone? See, heat affected zone is the area or portion of the metal very near to fusion zone. During welding process, that portion will be affected by the temperature, and it will be get heated below melting point, and the microstructural changes will be happening in that portion, that is known as heat affected zone. The welding heat will affect that portion of metal. How it will be affected? The microstructural change will be happening at that portion by heating and cooling below melting point. Below melting point, that portion will be get heated. See, this HAZ consists three portions. First one, grain growth region. Second one, grain refined region. And third one, transition zone. So these three are the three zones in HAZ. So first one, grain growth region. See, this is a figure of different portions of HAZ. We have solidified weld metal, grain growth region, that is very near to fusion zone. Second one is grain refined region, and third one is transition zone. So these are three regions in an HAZ. Okay, grain growth region, grain refined region, and transition zone. So grain growth region, base is heated to a temperature well above the upper critical temperature, below melting point. Grain growth and coarse grains will be formed. So in grain growth region, the base metal that is heated to above the upper critical temperature. So grain growth will be take place, coarse grain structure will be formed here. So here coarse grain structure will be formed here. And this area that is heated to above upper critical temperature, below melting point. Second one is grain refined region. Base is heated to just above upper critical temperature, where grain refined is completely and fine grain structure formed. So the second region of HAZ is grain refined region. In grain refined region, fine grained microstructure will be formed. In that region, the metal is heated just above the upper critical temperature. First one, the metal is heated well above the upper critical temperature. Here, the portion of metal that is heated just above the upper critical temperature. So here, fine grained structure will be produced. And third one is transition zone. Transition zone means the temperature between upper and lower critical temperature. So this is the transition zone. Almost nothing will be happening. The temperature between upper and lower critical temperature. So these are the three regions in an heat evaporated zone: grain growth region, grain refined region, transition region. In grain growth region, the portion of the metal is heated well above upper critical temperature. Coarse grain structure will be produced. In grain refined region, the portion of the metal is heated just above upper critical temperature. Fine grain structure will be produced. And third one is transition zone between upper critical temperature and lower critical temperature. So in this portion, the metal is heated between upper critical and lower critical temperature. Okay. Then heat treatment of welded joint. What is the importance of preheating and post-heating of welded joint? Preheating means the welded joints will be heated before welding process. Welding area will be get heated before welding process, and post-heating means after welding process the joint is get heated. So preheating and purpose. Preheating means heating a joint to be welded before or during welding to a certain temperature. The preheating reduces the rate of cooling after welding. First important point. The preheating reduces rate of cooling after welding. This is necessary to prevent the weld metal from cracking in restrained or rigid joint. So what's the importance of preheating is, preheating reduces the rate of cooling and reduces the crack will be developed. Prevent the crack will be developed. Okay. The preheat temperature can be checked by using temperature indicating crayons. So temperature indicating crayons that are used to check the preheat temperature while preheating. See, if a job and area to be preheated are large, then it is done in a preheating furnace. If we have a large job, preheating is conducted in preheating furnace. And if a small localized preheating is applied to the joint area only, this is called local preheating. So here we have preheating furnace for preheating large workpieces. Small workpieces we have localized preheating is done. The next one is post-heating. Post-heating means heating the welded joint after welding. Post-heating means that parts to be heated immediately after welding. The reason for post-heating are to prevent hard and brittle spot from forming the weldment. That's an important one. Post-heating is used to prevent hard and brittle spot. It also relieves residual stress caused by welding heat and due to welding of rigid joint. That second purpose, it is used for relieving residual stress. Post-heating retards the rate of cooling of the welded joint. So post-heating process, there are three purposes. First one, it relieves the residual stress. Second one, it prevents hard and brittle spot, and it reduces the rate of cooling in the welded joint. See, for avoiding residual stress, a welded joint usually normalized or annealed. Residual stress കുറക്കാൻ വേണ്ടിയിട്ട് വെൽഡഡ് ജോയിൻറ്റ്സ് എല്ലായ്പ്പോഴും നോർമലൈസേഷനോ അനീലിങ്ങോ ഹീറ്റ് ട്രീറ്റ്മെൻറ്റ് ചെയ്യാറുണ്ട്. So commonly using heat treatment are normalizing, hardening, case hardening, tempering, quenching and stressing. That is a commonly using heat treatment. In welded joint, we are performing normalizing and annealing in order to reduce the residual stress. Okay. So in this video, I have discussed about weldability of a material. What are the factors affecting weldability? Weld zone, 3 zones in a weld zone, heat effect zone, 3 zones in heat effect zone, then preheating and post-heating of welded joints. Thank you.